My name is Clif Kussmaul, and I'd like to tell you about POGIL, Process-Oriented Guided Inquiry Learning, and some of the ways POGIL might relate to Sensor and the Sensor community. First, a bit about me. I consult on educational practices and software development. Previously, I taught computer science at liberal arts colleges, developed software products, and consulted for a variety of organizations. I've also had Fulbright grants for work in India, Ghana, and Vietnam. Today, I'd like to tell you about three things. First, how POGIL works. Second, why POGIL works. And third, what the POGIL project is and the POGIL community. So imagine a classroom where student teams collaborate to process information, think critically, solve problems, and share their insights and questions. These are the skills that employers want and students need. How do we help students to develop these skills? Well, in a POGIL classroom, students work in teams to discuss questions and solve problems. The instructor is not a lecturer, but an active facilitator who observes teams and leads classroom discussions. In POGIL, each team member has a role that focuses on specific skills. For instance, the recorder takes notes, and the presenter shares answers with other teams. The roles rotate to help students practice all of these skills. Each POGIL activity is specifically designed with one or more models for students to investigate. Models can take many forms, including diagrams, graphs, tables, pictures, definitions, or computer source code. Each model is followed by questions that follow learning cycles to help students construct understanding. In each cycle, students explore the model, invent their own understanding of a concept, and then apply what they have learned. For example, here is a model that briefly describes a research study with plots showing grades for students in lecture courses and POGIL courses. Here are some questions about the model, which guide students to understand the plots, develop their own understanding of important ideas, and then consider some implications. Note that this is a very simple example. Typically, an activity will take 30 to 60 minutes with several models and many more questions. POGIL also focuses on the process of learning, so it helps students to develop important process skills. These match lists of skills most desired by employers. The POGIL website has definitions, assessment rubrics, and other information. Research studies show that student outcomes improve as learning experiences progress from passive to active to constructive to interactive. Thus, the most effective experiences tend to involve social constructivism, working together to figure things out. POGIL has been used for 20 years, first in chemistry and now across STEM disciplines and beyond. It scales to large classes and is based on learning research. Nearly 80% of studies find that POGIL improves student outcomes. Surveys and interviews typically find that students are more engaged and learn more in POGIL, although some feel that POGIL requires too much effort. Teachers agree with the student benefits, but also note that POGIL can take more time, especially at first. The POGIL project, like Sensor, is a community of transformation for STEM education. The POGIL project offers a variety of workshops and other events to train faculty and support the POGIL community as it continues to grow. People in the POGIL community have led POGIL workshops across the US and in a variety of other countries. I've led workshops in India, in Vietnam, in Ghana, and in Switzerland. I look forward to discussing ways to leverage and combine Sensor and POGIL. As a final thought, here are some ways to combine them as anagrams. For more information about POGIL and the POGIL project, check out our recent book and several of our websites. Thank you very much for your time.